Hello, I'm Phoenix City Council Member Carlos Garcia with District 8. We will never replace in-person teaching, but during these trying times, our children still need to continue to learn. The City of Phoenix is proud to partner with both the Osborne and Roosevelt school districts to bring you PHXTV Classroom Study Hall. Youth and education is a priority for Phoenix. That's why the city is bringing you the study hall to your home during this next hour right here on Phoenix TV. Learning should never stop, so get ready for class. Here's the study hall.
Hello friends, and welcome to our reading corner. I'm Mrs. Fletcher, a second grade teacher at Solano Elementary School in the Osborne School District, and someone who's really lucky because I get to share with you one of my favorite things to do, which is reading. That's right, reading's like a free vacation. I don't have to pay for anything. I can go to distant lands and meet new people and learn new things. Reading helps my brain get stronger. So I love it. And today I have some really great books I can't wait to share with you. But first, we have to do one of the most important things. What's one of the things I have to do before reading? Before singing? Before other fun activities? That's right. We have to say hello to all of our friends. So let's do that first. And what's really great about our hello song is that we get to do it with sign language, in English, and in Spanish. So the first sign that we're going to use is hello. We're going to use how are you. We're going to use a high five hand to do our fine. I'm fine. I'm fine. Then you take your other high five hands and show them that you hope you are too. Great. And then those will be the same actions, just in Spanish. All right, here we go. Ready? We're going to do this 2 times, my friends. Okay, so we'll sing it the one time, and then we'll do one more time. Okay? That way everybody gets to join in and see it and do it again. Hello, 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 how are you? I'm fine, and I hope that you are too. One more time. There you go. Hello, 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 how are you? I'm fine, and I hope that you are too. Great job! Round of applause. Now let's do it in Spanish. Here we go. Hola, 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 ¿cómo estás? Muy bien, espero que tú también. Uno más vez. Hola, 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 ¿cómo estás? Muy bien, espero que tú también. Yay! Round of applause. I'm so happy and excited. That's excited. Happy. So great. So before we get right into our book, I want to do something with you that we may know and a lot of adults know, but I'm going to tell you a secret. Sometimes when adults sing this song, they go really fast and they change the way some of the letters sound. That's right. I'm talking about the alphabet. Sometimes when my grown-ups sing the alphabet, they sing I-J-K, elemental P. Elemental P. It's not one word. It's not one letter. So we got to help our grown-ups out. Are you with me? So I'm going to teach you a trick. When you sing the ABCs, you can either tap each letter, but sometimes grown-ups will just tap with the beat. They like to get into the ABCs. A better way to get them to do this is to march. You can stop. See, I'm marching with my feet like this so you can see me and hear it. So we want to tap for each letter. So when we sing the alphabet, or also known as the ABCs, I'm going to sign it, and I'm going to use both hands. You don't have to, but that way my hands like to get involved, and it's part of my body liking to move. When I move and I get more oxygen to my brain, again, stronger, and helps me remember and listen. All right, here we go. We're going to try it. So we're going to march the ABCs, and I'm going to use sign language so you can see each letter. A, B, C, D, E, F, G. Good. H, I, J, K, L, M, N, O, P. So hard. Q, R, S, T, U, V, W, X, Y, and Z. Now I know my ABCs. Next time, won't you sing with me? Round of applause, my super friends. Round of applause. So just remember, you can march or you can tap, but just make sure that you tap or march and step with each letter, not just the song. All right, friends, I have a really fun book for you right now. And if you want to join in at home, you totally can. It's called Shh, We Have a Plan by Chris Haughton. Ooh, look at these colors. Isn't that a beautiful blue color? Like it. Oh, even deeper. That's like an indigo right there. Shh, we have a plan. Oh, where are they? Looks like they're in a forest. And it looks like they're carrying nets. I wonder what's going to happen. Look! A bird! Hello, birdie! Shh! Shh! We have a plan. Tiptoe slowly, tiptoe slowly. Now stop! Oh, they're creeping up on the bird. Ready one, ready two, ready three. Go! Look, up there. Hello, birdie. Shh, shh. We have a plan. Climbing slowly, climbing slowly. Now stop. Shh. Ready one, ready two, ready three. Go! Ah! Gotta wait. Oh, look down there. Hello, birdie. Shh, shh. We have a plan. Paddling slowly, paddling slowly. Now stop. Ready one, ready two, ready three. Go! Ah! Oh, my friends, what do we have here? Hello, birdie. Would you like some bread? One, two, three. Look! What do you see? Whoa! He got all the birds. Another guy. Uh-oh. Ready 1, ready 2, ready 3. Oh! Ah! Who was that? That's the boss bird. He doesn't look happy. Run away! Dun, 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 dun. And they're running, and they're running, and they're running all the way through the night. Oh, there's the moon. Look! A squirrel! Shh! We have a plan. What do we learn from that? Maybe you get more birds with bread instead of chasing them with nets. You never know. All right, my super friends. So we did a little bit of marching, a little tapping, and that was with a song that we knew. And I want to do another song that we know and change it a little bit, because using familiar songs that you know, a familiar rhythm, and then changing it a little bit helps you remember things. So we know the song, I'm a Little Teapot, or maybe you don't, and you'd love to learn it. And we'll sing it real quick. I'm a little teapot, short and stout. Here is my handle, here is my spout. When I get all steamed up, hear me shout. Tip me over and pour me out. It's a really sweet little song. I love that song. Now I want to pick it up just a little bit. And I want to make it a song that you think about. You can hear the rhythm and you can hear the words. So if you want to stand up, start marching, or you're sitting, you can march with me. Let's do it together, okay? Here we go. I'm a little teapot, short and stout. Here is my handle and here is my spout. When I get all steamed up, hear me shout. Tip me over and pour me out. Isn't that fun? Let's try it one more time, a little faster. I'm a little teapot, short and stout. Here is my handle and here is my spout. When I get all steamed up, hear me shout. Tip me over and pour me out. Whew! That'll get your heart going, your oxygen going, and I feel great. But I also feel a little bit tired. Oh, my friends, I feel so tired. Oh. It must be our book. What? Everyone is Yawning. By Anita Bajorshbush. Wow. Let's check it out. Everyone is yawning. There's my friend, the raccoon, the snake, an owl, and a pig. Ooh. What color is this? This is green. That's right. This color is green. It's kind of a minty green. Everyone is yawning. The kitten is tired. Can you see? Look, the kitten is yawning. The snake is yawning too. What a funny tongue. Look at that yawning snake. Is the raccoon tired? Oh, yes. Look, the raccoon is yawning. The bunny is yawning very quietly. Oh, let's see if we can hear it. I got to count his 4 teeth. The pig is yawning noisily. It grunts a bit. The pig is very tired. Ooh, who is this? Who is this one? Ah, crocodile. Yeah, it could be an alligator too, but here they say it's a crocodile. The crocodile shows all its teeth when it yawns. Ah! And there are a lot of teeth. Ah! Don't go near a crocodile or an alligator, even if they're yawning. Ooh, and the hippo? The hippo yawns too. 3 times. Yeah. Yeah. Thank you, hippo. Off to bed now, Arctic fox. Can you see the Arctic fox yawning? That's what a fox says. The turtle yawns very slowly. The little turtle is ready for bed. And the little child? Is the little child going to bed too? Oh, yes. One more yawn. Hey, look at his little teeth. And off to bed. Shh, the owl whispers. Everyone is sleeping. Oh, what a nice book, my friends. What a nice time. All right, it's time to do our closing songs. So let's get our hands out. Here we go. My hands say thank you with a clap, clap, clap. My feet say thank you with a tap, tap, tap. Clap, clap, clap. Tap, tap, tap. I roll my hands and say goodbye. All right, and let's do our final song, which is our goodbye song. Again, we're going to get out our hands. We're going to say goodbye. And we're going to say to our friends, it's time to say goodbye. Here we go. Goodbye, friends. Goodbye, friends. Goodbye, friends. It's time to say goodbye. Aw, thank you so much for spending this time with me here in our reading corner. I love that we get to share this time together, my fun books, the things we get to do together. So just keep on singing, keep on reading, march out those letters, and I will see you next time. Thank you so much for coming. Bye, friends!
Hi, everyone. It's Mrs. Hughes again from John F. Kennedy Elementary School, and this is Math Time with Mrs. Hughes. For today's topic, we're going to be discussing something that has to do with marshmallows. It can get a little bit sticky, and you have to cook it over a campfire. What could today's topic be about? You're right! S'mores. Yum. And I need help figuring out how to make them. Do you guys think that you could help me today? Awesome. So what will we need to make s'mores? Well, we're gonna need marshmallows. We're gonna need graham crackers, chocolate bars, skewers to cook the marshmallows over the fire safely. And last but not least, we're gonna need a campfire. So the first thing that we need to think about is what exactly are we gonna need in order to make one s'more? So when I think about it, I know that we're gonna need a marshmallow, one full piece of graham cracker, and we're gonna need 6 pieces of chocolate, which is half of an entire chocolate bar. So those of you that know me know that I'm not just eating one s'more. I'm gonna need more than just one. So I'm gonna need your help figuring out how many of each material I'm gonna need in order to make more than one. Something else we're gonna have to think about is that Mr. Hughes is here today with us, and he's also really hungry, and he's not just gonna want one s'more. So let's figure out how many of each material we're gonna need in order to make more than just one s'more. If Mr. Hughes and I each want 3 s'mores, how many of each item will we need? Well, I remember that we said for one s'more, we're gonna need 1 marshmallow, 1 graham cracker, and 6 pieces of chocolate, which is half of a whole chocolate bar. So to help us figure this out, I created 2 different groups. One group for me and one group for Mr. Hughes, so that it's easy for us to put all of my materials that I'll need for my s'mores in my group, and we'll put all of the materials that Mr. Hughes is gonna need for his s'mores in his group. So let's go ahead and we can start with the marshmallows. So if for one s'more, we need 1 marshmallow, that means for 3 s'mores, we're gonna need 1, 2, 3 marshmallows. So I get 3 marshmallows, and then how many marshmallows is Mr. Hughes gonna get? 3? Let's see. 1, 2, 3. Does that make sense? Yeah, because we each want 3 s'mores. So we're each gonna need 3 marshmallows. Good. So now let's think about the chocolate. We said that we were gonna need 6 pieces of chocolate for each s'more, or half of a chocolate bar. So let's go ahead and we'll sort out our chocolate, and we can count how many pieces we're each gonna have when we're all done sorting. So I get a half. 1, 2, 3. 1, 2, 3. So now let's count how many pieces of chocolate each of us are gonna need. One of my favorite things to do when I'm counting a lot of different things, I like to put a little dot on each object after I've counted it, so that I make sure that I'm not going back and recounting that and accidentally getting the wrong number. So let's go ahead and see if that helps us. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I'm gonna need 18 pieces of chocolate for my 3 s'mores. So how many pieces of chocolate do you think that Mr. Hughes is gonna need? You think he's gonna need the same? So he's gonna need 18 pieces of chocolate too? Let's count just to double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 pieces of chocolate. Were you right? Yeah, good job. The last ingredient that we need to make our s'mores are the graham crackers. So if we're making 3 s'mores, how many graham crackers are each of us gonna need? I remember that we said we need 1 full graham cracker in order to make 1 s'more. So how many graham crackers do you think that each of us are going to need? 1, 2, 3. 1, 2, 3. So how many graham crackers do each of us need? 3, right. So each of us will need 3 marshmallows, 18 pieces of chocolate, and 3 graham crackers. All right, so we've got all the materials sorted. Now we need to count to figure out how many of each item we're gonna need. So let's start with the marshmallows. How many marshmallows are we gonna need all together? Let's count together. 1, 2, 3, 4, 5, 6. So how many marshmallows are we gonna need? Yeah, 6 marshmallows. 1, 2, 3, 4, 5, 6. So how many halves of a chocolate bar are we gonna need? Yeah, we're gonna need 6 halves. All right, and our last item in order to make our s'mores is our graham crackers. How many graham crackers are we gonna need? Let's count. 1, 2, 3, 4, 5, 6. So how many graham crackers are we gonna need all together? You got it, 6. So we're gonna need 6 marshmallows, 6 halves of chocolate, and 6 whole graham crackers. So I found these marshmallows on my counter. How many do you see? How did you count them? When I look at this, the easiest way for me to count how many there are total, I see 2 different groups. I see this group down here, which is 1, 2, 3, 4, 5, 6. So I see that group of 6, and then I see 1 more up here. So I know that that's 6 plus 1. 6 plus 1 equals, let's put 6 in our head and count up 1. 6, 7. So what's 6 plus 1? 7. Good job. How many marshmallows are on the counter? You're right, 7. What are some other ways that we could find the total number of marshmallows? One way is we could count every single marshmallow. We could go 1, 2, 3, 4, 5, 6, 7. Then we know that we have 7 marshmallows. Or we could continue breaking them up into different groups. Let me show you what I mean. I've split the marshmallows up into 2 different groups. How many are in each group? Well, I see that there's 1, 2, 3, 4 in the first group. And I know that we're adding these 2 groups together. So I'm going to use my plus sign. So we've got 4 plus 1, 2, 3. So 4 plus 3 equals what? 1, 2, 3, 4, 5, 6, 7. So 4 plus 3 equals 7, but I thought we said 6 plus 1 equals 7. Oh, they both do? You just blew my mind. Do you think that there is some more equations that we can find? What about this one? Can you look at these 2 groups and think of an addition equation? I know that no matter what, our answer is still going to be 7 because the amount of marshmallows that we have on the counter aren't going to change. But our equation is going to change a little bit based off of how many marshmallows are in each group. So can you think of an equation? So in these groups, I see 1, 2 marshmallows in the first group. And then I see 1, 2, 3, 4, 5. I see 5 in the second group. So now our equation is 2 plus 5 equals 7. That's 3 different equations that we've made in order to make 7. You guys are awesome. Shine those halos for me. Keep up the good work. So now we know that there's 7 marshmallows on my counter. But I remember that we said we're only going to need 6 marshmallows total for Mr. Hughes and I to each have 3 s'mores. So do we have too many marshmallows or not enough marshmallows? I think we have too many. So how many are we going to take away in order to make 6? If we're taking away, what kind of math are we going to have to do? Addition or subtraction? That's right, we're going to have to use subtraction. So let's go ahead and make our subtraction equation. So I know that we want to end up with 6 marshmallows. So I'm going to put the number 6 at the end of our equation. I know that we're starting out with 7 marshmallows. So 7 is going to be the very first number of our equation. So now we have to figure out how many do we need to take away in order to get to 6. What we're going to do is we're going to put 7 in our head, and we're actually just going to count backwards until we get to 6. So 7, 6. How many marshmallows do we have now? Let's check. 1, 2, 3, 4, 5, 6. So how many marshmallows did we need to take away in order to get to 6? Just 1. Good job. 7 minus 1 equals 6. Okay, so I'm pretty sure that I've gathered everything that we're going to need in order to make our s'mores. But just to make sure that I didn't make any mistakes, can you help me count? So first, let's focus on the marshmallows. How many marshmallows did we say we were going to need again? That's right, 6. Okay, so let's go ahead and make sure that we have 6 marshmallows. 1, 2, 3, 4, 5, 6. Awesome. So we've got 6 marshmallows. Now, how many halves of chocolate did we say we were going to need again? Oh, that's right. We're going to need 6 of those too. So let's count to make sure we've got 6. 1, 2, 3, 4, 5, 6. Awesome. Do we have enough? Yes, we do. So we've got 6 halves of chocolate. So now we've got our 6 marshmallows, our 6 halves of chocolate. Now we just need to make sure we have enough graham crackers, which, how many did we need again? 6. That's right. 1, 2, 3, 4, 5, 6, 7, 8. Oh no. Do we have 6? Well, we do, but we have too many. We've got more than 6. So how many do we need to take away in order to get 6? Well, I know that we just said that we had 8 graham crackers. So let's put 8 in our head and count backwards until we get to 6. 8, 7, 6. How many do you think that we're going to need to take away? 2? Let's check. If we take away 1, 2, let's count to see how many we have. 1, 2, 3, 4, 5, 6. Do we have 6 graham crackers now? Awesome. Since we just took something away, that makes me think of a subtraction equation. How would we write a subtraction equation for what we just did? Well, I know that we started with 8 graham crackers, so that's going to be the first number in our equation. Then we took away 2, so that's going to be our second number. And then I know that we ended with how many? 6, that's right. So 6 is how many we ended with. So our subtraction equation is 8 minus 2 equals 6. So now that we've counted to make sure that we have enough materials to make all of our s'mores, now do you think you could help me sort our materials? How would you sort the materials? How many different groups are we gonna have? Let's check together. I know that we've got 3 different materials: marshmallows, graham crackers, chocolate. So I think that we're gonna need 3 different groups. Do you think that you can help me sort? All right, let's go. So now that we're done sorting, we have all of our marshmallows together, all of the chocolate together, and all of the graham crackers together. And I've also separated them so that I know which materials I need and which materials Mr. Hughes is going to need. Now that we've sorted everything, it's time to get everything assembled so that we can get to the best part.
So now it's time to get our s'mores ready to eat. We're going to prepare each one so that after we cook our marshmallow in the campfire, they'll be ready to go. So what we're gonna do is for every graham cracker, we have to split it in half, just like that. We're gonna have a bottom and a top. All right, so I have all of our tops over here above our marshmallows. Now what we're gonna do is we're going to put our chocolate on our bottom piece of graham cracker. Perfect. So now we're all set, and then after we cook our marshmallow, we will put it on top of the chocolate and smash it with our top piece of graham cracker to make our s'more. So we're out by the campfire. Make sure that if you're gonna make a fire that you ask an adult for help first. The first thing that we're gonna do is we're gonna get our marshmallow and put it on our skewer. Now we're gonna carefully put it over the fire. Don't have to get too close. We're gonna cook it until it's golden brown. So now that it's nice and toasty brown, I'm gonna get my graham cracker and my chocolate and do the smash. Oh yeah. Thanks for helping me make my s'mores tonight. I've had a great time and I hope that you did too. Join me next time on Math Time with Mrs. Hughes.
Okay, before we begin our lesson, we need to make sure that we are practicing our fluency. Fluency is important so that we can learn numbers and how to add and subtract super quickly. That way we don't have to waste time counting with our fingers or counting with objects. The first thing we're going to do is practice our number recognition. I'm going to give you a number, and if there is an arrow going up, that means you have to count up. If there's an arrow going down, that means you have to count down, okay? Let's practice. Here is this one. The number is 27, okay? Keep 27 in my brain. Now I'm going to, this arrow says count up. So then, let's ready. Do it together. 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, and you stop. What number was that? 36, correct. Write 36 in the sky. This time, the arrow's gonna go down, which means that I have to count down. It's a little bit more trickier to count down than it is to count up. So make sure your brain is wide awake, turn it on, and be ready. The number is 95, correct. What number is it? 95, correct. And the arrow again says count down. So when I count down, I have to keep 95 in my brain. 95, 94, 93, 92, 91, 90. What comes below or under 90? 89, 88, 87, stop. What number was that? Good job, 87. Let's write 87 in the sky. 8 tens and 7 ones. Here's another one. Ready? This time I'm not going to help you. I'm just going to say stop. Ready? The number is 72. What number is it? 72. And you're going to count down. Ready? 72. Stop. Let's see if you have the same answer as I do. What number do you have in your brain? 1, 2, 3, tell me. The number I had was 64. Did you have 64? Show me like this. This in my classroom means me too. Good. 64 looks like 6 tens and 4 ones. Last one. We're practicing counting. The number is 65. And this time the arrow is telling me that we need to count up. Okay? 65. Keep 65 in your brain. 65, 66, 67, 68, 69, 70, 71, 72, 73, 74. Stop. What number was that? 74. Good job. Can you draw it in the sky? Beautiful job. Hey, now you smart cookies. Now I'm going to challenge your brain again. Remember that we're working on fact fluency. So fact fluency is adding, or maybe even subtraction, or when you get older, it's even multiplying or dividing. Right now, all we're going to do is we're going to work on addition, plus. So I'm going to show you some slides, and you just have to tell me super fast what is the answer, or the sum, okay? For example, here is sum. 0 plus 2, tell me, 2. Good. 8 plus 7, 15, if you knew it, kiss your brain. 4 plus 9, 13, correct. Remember that we're trying not to use our fingers to count these. They should be really quick. You can do some mental math so it can help you add correctly. 5, easy peasy, lemon squeezy. And 7 plus 6, 13, correct. That one's easy peasy, 10 plus 4, 14. 6 plus 0, 6. 7 plus 9, move 1 over, that's 10 plus 6, 16. These are all mental maths that you should be working on. Let's do one more. Oh my goodness, do you guys know what 10 plus 10 is? 10 plus 10 is 20, correct. Kiss your brain and shine your halos if you were correct. Good job. Now, that was just a quick review of the stuff that you should be working on for fluency to help you be quicker. But now we're going to go ahead and begin our actual lesson. The lesson is going to be targeting the same goals that we had last week, which we can talk about in a little bit. Get ready for this, learners. You can do it. Today we're going to work on using number lines to help us add and subtract numbers within 100. So a lot of us have been using these in your classroom as tens. And then you've also been using these as ones, correct? Now, if I were to use them in my camera or on the screen, it's kind of hard to keep adding a lot of tens and ones. So instead, I'm just going to pretend that one big jump is a 10 and a smaller jump is a 1. For example, this could be a big jump. And every time I jump big, that means I add 10, which is this. If I do a smaller jump, this is going to be adding 1. So add 10 and then add 1. 10 and 1 makes 11. 10 plus 1 makes 11. Okay, so we're going to practice. Here is a word problem that we have. We're going to go ahead and do it on our paper. 45 plus 14. Let me write it down. Go ahead and try it out. So I'm going to first, remember that draw a number line. The number line should be nice and long because we don't know how many tens and how many ones we're going to add. Before we maybe sometimes even have to make it longer, like you just saw me doing right now. I had to make it longer because it was not fitting in my number line that I had created. So I made it a little bit longer. First, we had 45 something. Maybe we can say 45 hot dogs, 45 books, 45 pencils. Let's just say 45 hot dogs. Then maybe we had 14 more. So 14 has 1 10 and 4 ones. So we're going to add 1 10. Remember that the tens look like a bigger lump because it's 10 units or 10 spaces. So plus 10. 45 plus 10 will make, well, if 45 has 4 tens, I add 1 more 10. It's going to be 5 tens. 5 tens, 5 ones is 55. Now we're going to add the ones. We need 4 ones. So plus 1, plus 1, plus 1, and stop. Let's check. 1, 2, 3. Oh, we don't stop here. We need to keep going. We need 4 ones, not 3 ones. Plus 1. And then we just stop and leave it like this? No, that's not our final answer. We need to make sure that we're adding them together. So 55 plus 1, 56. 56 plus 1, 57. 57 plus 1, 58. 58 plus 1 more, what is it? 1, 2, 3, tell me. 59, good job. Superstars working together to use a number line to help you. So 45 plus 14 equals 59. Don't forget to always go back and answer your question or your equation so you can show what you're thinking and knowing. Look at this great strategy we learned. Now, if we wanted to tie it back to what we learned last time, we can just go ahead and draw tens and ones. Good learners always use different strategies to help them solve math problems. 45 has tens and ones, and then tens and ones. 4 tens, remember that tens look like this? And 5 ones. 1, 2, 3, 4, 5. 1 10. 14 has 1 10 and 4 ones. 1, 2, 3, 4. Let's count the tens. 1, 2, 3, 4, 5 tens together. And then 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 ones. Beautiful job. Superstars. If you are getting it correct, tell yourself, I'm good stuff. Awesome. Now, here is a challenge. We've been working a lot on addition equations and we haven't really talked about subtraction. So we're going to practice a little bit of subtraction today, and then the next week we're going to do a lot more subtraction. So be ready for that, okay? Pay attention to how we do subtraction, because it's putting together is counting them easily, but then when you subtract, you have to take it away, which is a little bit more challenging if you don't pay attention to how you're taking things away. Let's go ahead and be ready to prepare for it, figuring out how to subtract within 100. Remember that we're still working on the same objectives as last time. So last time we said we will be able to relate counting by tens to add within 100, which means we're going to connect counting by tens to add within 100. We would also are going to practice using addition and subtraction to help us solve word problems within 100. A word problem, remember, is a story using numbers. So today we're going to really work on using addition and subtraction to solve word problems. We practiced some already with addition, and then our goal now is to practice some with subtraction. Let's go ahead and try reading this problem together. Before that, I'm going to give you a chance to read it by yourself. Okay, let's read it together. Joanna had to solve 54 math problems. She already solved 31 problems. How many problems does she have left? Okay? So, the first thing we need to do is figure out what do we know? Well, we know that she had some math problems. She had to solve how many problems? 54. So in total, she had to solve 54 problems. Then we already know that she also already solved 31. So she already did that. She's going to do it again. She solved 31 problems. And now we know that we need to figure out how many are left. So that's a big important word. Let's pretend that you are Joanna or your student. Sometimes you get math problems too. So let's pretend that you have 54 problems. Show me 54 problems. Now, show me that you already solved 31 problems. So I'm trying to solve 31 problems because it says I already solved it. Now, here are how many I have left. Do you think this is an addition or subtraction word problem? And how do you know? Going back to what we know about plus means you put together, minus means you take away. Are we putting things together or did we take some away? We took some away, which means that we're going to subtract. So we know the whole is how many in total. In total, she had 54 problems. We also know that she had 31 as a part. She solved those already, which means that this part right here is how many she will have left. Let's go ahead and figure it out. She had 54 problems. So I'm going to draw 54. Let's just do green. We'll use red right now. 54, I'm going to use my tens and ones. 10. 54 should have 5 tens and 4 ones. 3, 4, 5. 10, 20, 30, 40, 50. 54 should also have 4 ones. Okay? Now, if she solved 31 of those problems, so this means I can take them away. I don't need them anymore because I already solved it. So Joanne, so I'm going to take off 3 tenths. 1, 2, 3. And I'm going to take off 1, 1. How many tens are left? So if I see this, let me write the equation first before I solve it so I know what my equation looks like. 54, which was the whole or the total, minus 31 can equal, do you know what the answer is? Well, I see 2 tens are left, and I see 3 ones are left. So if I put that together, the answer is 23. So how many problems does she have left? 23, what? 23 problems left. Nice job. Now I'm going to give you another problem so you can practice at home. Okay, be ready with the paper and pencil. Here is our problem. The problem I'm asking you to solve is 87 minus 62. So let's write it together. 87 minus 62. Remember that this is subtraction now, so we're not putting things together anymore. We're going to take them apart. Take away. Minus means you take away. So the first thing you're going to do is draw the whole. 87 is the whole. And if you think about it, how many tens and ones do you need? Sometimes you can label it to help you if you're still practicing your tens and ones. So we have 8 tens, 4, 5, 6, 7, 8, and 7 ones. 1, 2, 3, 4, 5, 6, 7. If I'm going to take away, I can cross them off because I don't need them anymore. 62, so I'm going to challenge you to do it faster than me to see we have the same answer. You have 87, take away 62, and wait for the answer, see if you're correct, okay? 6 tens, so 1, 2, 3, 4, 5, 6, and 2 ones. 1, 2. First you count by tens, then you count by ones. There are 2 tens left. 1, 2, 3, 4, 5. And 5, 1. So our final answer is 25. Do you agree? Superstars. Okay, so we're going to keep having you go and practice some more adding and subtracting. So there can be any numbers you see. If you see numbers in a cereal box, if you see numbers in another TV show, maybe you can try adding or subtracting so that you can keep getting more knowledge. Remember, the more you practice, the smarter you can get. I know you can do it. You are all learners, leaders, and achievers. Thank you for watching, and we'll see you again next week.
Good morning, students. I'm Michael Roberts, Superintendent of the Osborne School District in Central Phoenix.
And I'm Quentin Boyd, Superintendent of the Roosevelt School District in South Phoenix.
We're pleased to have this partnership with the City of Phoenix to take Phoenix students on a new learning adventure right here on Phoenix TV.
Just because our school buildings are closed doesn't mean the learning stops.
We have the best, most creative teachers from Roosevelt and Osborne school districts on board to provide you with a great learning experience.
Okay, students, that's the bell, so the Phoenix TV Study Hall resumes. Here's your next lesson.
Hi, and welcome to our classroom. I am Mrs. Huvetta, and I am a teacher at Maxino Bush Elementary School. I teach 3rd grade. So a little something about myself before we begin. Last time I was here, I spoke to you guys about my 3 dogs, Curly, Kobe, and Bailey. And today I'm going to share something special about Curly. So Curly is more like a human more than he is a dog, right? So, and I'm sure you're thinking, A human? How is your dog like a human? Just like we like to lay down, he likes to lay down too, but Curly lays on his back, legs in the air, and even if he's sleeping, he will try, if you let him, to sleep on your pillow. Enough about me. I'm ready to get started because the real reason we are here is to work on math. Today we are going to be working with multiplying 3- and 4-digit numbers. Before we get started, you know that I love songs, so we're going to start off with a song that you all know. And it might not seem like the song has anything to do with our lesson, but believe me, I'll let you know in just a little bit. The song that we are going to be doing is Row, Row, Row Your Boat. So just a reminder in case you don't know it or haven't heard it, it goes row, row, row your boat gently down the stream. Merrily, 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 life is but a dream. So we're going to sing it only one time. Before we sing the song, I'm going to tell you what our celebration cheer is for the day. So whenever I'm in my classroom and my students share and they do a fantastic job, which is all the time, I celebrate them. And so I want to celebrate you at home as well. The celebration cheer for today is going to be the truck driver. Just like the truck drivers that drive the big 18-wheelers that are busy delivering to stores, we are going to pretend that we have a steering wheel. We're going to go one way, then go the other, and we're going to make noises while we do it. So we're going to go, pull down your microphone. Good job, buddy. Just like that. You ready to do it with me? Good job, buddy. So every time you do a good job, I'm going to celebrate you with the truck driver, and I want you to celebrate at home as well. Let's get back to our song. Row, row, row your boat, one time only. Are you ready? Row, row, row your boat gently down the stream. Merrily, 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 life is but a dream. Good job, you guys sounded great there. Now let's get back to what we're going to change it to. We're going to use row, row, row your boat and change the words to numbers. A big thank you to Miss Claren Harley, who's a 4th and 5th grade teacher in Phoenix Elementary District, for letting me borrow her song. We're going to change it, and this first time, I only want you to listen. What do I want you to do? Listen. Thanks, I knew you were watching. I'm going to sing it the first time all the way through, and after I sing it the whole way through, you're going to join in with me the next time. Ready? 4, 8, 12, 16, 20, 24, 28, 32, 36, and 40. Pretty easy, right? So the same song, the same tune you know to row, row, row your boat, but we're going to skip count with 4s. This is going to help us when we are multiplying to get to our product or our answer a lot faster than counting by ones. So I'm going to sing it one more time and then you're going to join in. 4, 8, 12, 16, 20, 24, 28, 32, 36, and 40. Ready to join in now? I'm going to sing it and I'm going to point to myself. When it's your turn, I'm going to point to you all at home and I want you to repeat the same numbers I repeated. We're only going to do it once. This is our warm-up for us going into our lesson. Ready? 4, 8, 12, 16, 20, 24, 28, 32, 36, and 40. Great job. Time to celebrate. Good job, buddies. Keep up the good work. We are going to be using that skip counting song throughout the time that I am with you guys. It's time for some brain work. I know you've been at home. You can't wait to exercise all of those skills that you know. But to get you warmed up, I always start off by modeling one for you. So what we're going to be doing is we're going to expand some numbers. Expand is a way of saying we're going to stretch them out. The way that we're going to do this is we're going to look at the hundreds place, the tens place, and the ones place. Here is my number, 343. If I expanded this, the way it would be written is 300, there's a 3 in the hundreds place, plus 40, that's the 4 in the tens place, plus 3, and that's the 3 in the ones place. Now, I'd like you to do it with me. I have a larger number this time. So this time, I have a number that has 4 digits. So a thousands place, a hundreds place, a tens place, and a ones place. So let's start off with the thousands place. If I take a look at the thousands place and I only add what's in the thousands, I know that the first digit is going to be a 4, but that means I have nothing in the hundreds, tens, or ones, so it's going to be 4,000. To keep track that I've already used that number, I'm just going to draw a little line underneath it. Let's take a look at the next place value. 6. That's not 6, that's 600. So 4,000 plus 600, that's 7. You got it, that's 7 tens. That equals 70. And the last place value is ones. That's just a 9. So if we expand 4,679, it would actually be 4,000 plus 600 plus 70 plus 9. Great job. Good job, buddies. I took a chance now, and I switched the numbers just to make sure that you're keeping up with me at home. I know you guys are so sharp that this is going to be a piece of cake. I went ahead and wrote it in expanded form, and I want to switch it from expanded form to standard form. So let's take a look at the numbers that I have here. 500 plus 8 plus 20. I have to think, if I wrote this, which number would go first? I know that the largest place value will go first, and that is 500s. Same strategy I used before. I'm going to underline it to show I already used it. Would it be 508.20 or 528? You're right, I thought the same thing. 20 goes next. I'm just going to put the 2. I'm not going to use the zeros. And the only thing we have left is 8. 528. Great work. Let's keep going. Show what you know. I have a number this time again in the thousands. So at home, you're going to be shouting out what goes first. Are you ready? If this number is 4,638, what number would go first if we expand it? I heard it, 4,000. What's that, Mrs. Huvetta? Make sure that you show you used it. Thanks. What goes next? You're right, 600. 4,000 plus 600. What goes next? I hope you said 3 tens or 30 and not just 3. So that is 30. And that last one, 8 ones plus 8. Celebrate you at home. Good job, buddies. We're going to be using expanded form today, and I'm sure you're thinking, what does this have to do with multiplication? We're going to be using those place values, the thousands, the hundreds, the tens, and the ones place when we multiply our 3 and 4 digit numbers today. Let's take a look at your warm-up. The place value we just used is going to be helpful when we multiply today. So this kind of looks really busy, right? I'm sure it does. But all I did was I circled the ones place first, and then I circled the tens place, and then I circled the hundreds place, and we're going to go in that order. 2 times 2 is 4. 3 times 2 is 6. And 4 times 2, well, we could use the song for that, right? 4, 8, stop, don't keep going. Even though the song is really great, we only need to skip count 2 times. Our total, or our product, is 864. You're going to help me now. Remember, we're going to start with the ones place first. 2 times 3, I could skip count by 2 3 times. 2, 4, 6. That's our ones place. Now let's move to the tens. 1 times 3 is, well, we can skip count by 3 1 time. 3, that's it. And then move to our hundreds place. 3 times 3, 3, 6, 9. Our product is 963. This is one that I would like you to do with your family. So whoever is in the room with you, mom, dad, brother, sister, grandma, grandpa, nana or tata, tia or tío, you're going to work with them. Let's see if they were watching. Start with your ones place. 4, 8. And your tens place. 4. And your your hundreds place, not your ones place. 8. Great job. The last one is for you to do alone. So I want you to jot this down on a piece of paper so you can work on this one at home. It is 124 times 3. Remember to do your ones place first, your tens place second, and your hundreds place third. If there was a thousands place, you would move to the thousands place and do that one last. Great job. Let's keep going. All of those problems are great, but what really matters is those real world problems, things that happen every single day. If I go to the grocery store, I'm always doing math, right? I want to make sure I'm getting the best buy for my money. Well, Mike's mom did the same thing. She doesn't want to have to keep going out to the grocery store, so she goes to the grocery store and she's buying 3 cartons of milk. We're going to find out how much she has in all. Mike's mom went to the store and bought 3 cartons of milk. Each carton contains 236 milliliters. Milliliters is the unit of measurement that we're going to use for this one. Calculate the total amount in all cartons. So we want to figure out if we added up or put together all of the milk from all 3 cartons, how much would there be total? To help us figure out our answer, we're going to take 3 steps. We read the problem, we're going to draw it, and then we're going to write it. So I already read the problem once, but I'm going to go back and read it again. And when I'm reading, I'm going to be looking for any information that's important and that's going to help me solve, okay? I know that they want to know the total amount in all cartons. Those words are important because I know what I need to search for. So let's go back and look for anything that has to do with all of the cartons of milk. Mike's mom went to the store, nothing there, and bought 3 cartons of milk. 3 cartons is important. Each carton contains 236 milliliters. That's important too. Each of them has it. I'm going to use 3 cartons and 236 milliliters to help me figure out how much there is in all. My first strategy I'm going to use is a tape diagram. I know what you're thinking. We used them before. That's exactly why I chose it again, because you now have it in your schema or your background knowledge. Remember, a tape diagram is like a great big piece of tape, and we're going to divide it into however many sections we need and put some information inside to help us keep track of what we are doing. So I went ahead and I drew my tape diagram already, and I have 2 pieces of information. I have 3 cartons that Mike's mom bought. So for this tape diagram, I'm going to divide it into 3 sections. 1, 2, 3. Each of the cartons has 236 milliliters. So instead of doing 236 dots, that wouldn't be efficient at all. I'm going to write the number 236 inside. So 236, 236, 236. And I'm trying to figure out the total. So I'm going to put a question mark there because right now that is unknown, but we're going to find it shortly. We read it. We drew something for a tape diagram. Now let's draw something for a hundreds chart. This is another way to help us with multiplying. Sometimes you need to visualize and see what you're doing. So remember we just worked with place value. We're going to do the same thing with the number 236 and we're going to show it 3 times. The way that we're going to do that is we're going to put a dot or a tally that represents the hundreds place, the tens place, and the ones place. So in the number 236, there are 2 hundreds, 3 tens, and 6 ones. 1, 2, 3, 4, 5, 6. But it doesn't do me any good to only do it 1 time. I need to do it 3 times. So that's 1. I need 2 more. 200, 30, 6. 200, 30, 6. Now what I'm going to do is, whenever you have 10 of any unit, it makes a new unit. So every time I have 10 ones is going to make a 10. Anytime I have 10 tens, it's going to make 100. So I'm going to go back, and I remember we counted by 6s. So I have 5 here and 5 here. That makes a 10. And then I know I have 6 right here. So my 10 that I made, I'm going to put it next door. That's no longer ones. That is now a 10. And I'm going to count what's left in the ones place. So that's 6, 7, 8. Now I'm going to do the same thing with the tens place, but remember, whenever I have 10 tens, it's going to make 100. That's 3, 6, 9, and 10. So that's no longer a 10. This becomes 100. And I don't have any tens left, so to hold my place, I'm going to put a 0 there. Now my last step is to count how many hundreds I have. 100, 200, 300, 400, 500, 600, and 700. My answer is 708 milliliters. Last step is to write it. Our job was to calculate the total amount of milk in all cartons. There is milliliters of milk in all cartons. There is 708. We are going to continue building our strategies, coming up with some tools that we're going to use to help us multiply. Thanks for helping me at home. Good job, buddies. Now it's your turn. I hope you have your pencil and paper. We did this strategy earlier, but now we're going to give it a name. The way that we multiplied our ones, tens, and hundreds by this one right here, that's called the partial product. The last step we just did was modeling with the place value chart. We're going to use both strategies to help us with 162 times 6. Feel free to shout the answer out at home. I'm sure your family won't mind. 2 times 6. I remember our 6's song. 6, 12. So I'm going to put the 2 right there. That made 12, so that means there's 110. I'm going to put a little tally right here to keep track of it. 6 times 6, 6, 12, 18, 24, 30, 36, 36. There's 3 tens and 6 ones. 36 plus that 1 right there, 37. So I'm going to put a 7 right here. I'm going to cross that off. I already used it. And right here, I'm going to put a 3. 6 times 1, 6 plus 3 more, 7, 8, 9. Our product or our total is 972. Now let's model it. So remember, we're going to show how many hundreds, we're going to show how many tens, and we're going to show how many ones. And this number tells how many times we need to show it. So I want to show 162 6 times. So that's 100, 60, 10, 20, 30, 40, 50, 60, 2. 100, 10, 20, 30, 40, 50, 60, 2. 100, 10, 20, 30, 40, 50, 60, 2. 6 times, let's keep going. 100, 10, 20, 30, 40, 50, 60, and 2. 100, 10, 20, 30, 40, 50, 60, 2. I had to double check. I needed to make sure I didn't write it too many times. That's 1, 2, 3, 4, 5, and one more time. 100, 60, 10, 20, 30, 40, 50, 60, and 2. Great job. I know I was moving fast, but I'm sure you were keeping up. Always start with your ones place value because we want to see what is going to be left over in this area and what we need to create a new unit for. So if I start with my ones, I have 2, 4, 6, 8, 10. I'm going to circle all of those. And it's not going to stay there. It becomes a new unit, which is a 10. What do I have left over? Just 2. That number is going to come down here. For the tens, remember we counted by 6s, so I want to think it would be more efficient for me to count by 5s. I know that 2 5s is going to make a 10, so that's 5, 10, 5, 10, 5, 10, and those 3 10s, 10 tens makes 100, so I'm going to move it over to the hundreds place. That makes 100, this one makes 100, and this one makes 100. Now I'm going to see what's left in the hundreds place. I'm sorry, the tens place. 1, 2, 3, 4, 5, 6, 7. Last step is the hundreds place. We're going to count the hundreds up. I could count by ones and put the number here because I know I'm in the hundreds, or I can count by hundreds. 100, 200, 300, 400, 500, 600, 700, 800, 900. Our product is 972. 2 very different strategies. One was a lot longer, but you could visualize how each place value changes. And the other way, the partial product was a lot shorter. Now we're going to take our partial product and we're going to do it again. You should be a pro at this one. And then we're going to do another strategy called standard algorithm, which is a little bit longer, using our numbers and showing the place value that it's in. Remember, with partial product, we're going to start with our ones, then our tens, and then our hundreds. 7 times 5. Oh my goodness. 7, 14, 21, 28, 35. The 5 goes there. The 3 for the 30 is going to go in the tens place. Now I'm going to multiply 3 times 5. 3, 6, 9, 12, 15, plus 3 more, 16, 17, 18. So the 8 is going to go right here. I already used this 3, I'm going to cross it off. And then the 1 is going to move over to the hundreds place. 2 times 5 is 10, plus 1 more is 11. Our product is 1,185. Let's show it in a different way. For standard algorithm, the way that we kept track where we regrouped and it moved over to this side, we're not going to do that with standard algorithm. When we multiply it, we're just going to write the numbers right where they are. And notice that I put a 0 here. That's because when we multiply the tens, there's a 0 holding the ones place. And when we multiply the hundreds place, there's 2 zeros holding the place of the ones and tens. 7 times 5 is 35. I'm going to write the whole number there. I can still circle it to show that I used it to keep track for myself. 3 times 5 is 15. Actually, 150 because it's the tens. And then the last one, 2 times 5 is 10, but that's actually the thousands place. Now it's time to add it all up together. 5 plus 0 plus 0, 5, pretty easy. 3 plus 5 plus 0 is 8, that's 8 tens. 1 plus 0, that's your hundreds, 1. And then 1,000 plus nothing, or 1 plus nothing is 1. Same product, 1,185, 1,185, just 2 ways to do it. Now you have multiple tools to help you solve. You can use the partial product. You can use the hundreds, tens, and ones, or a place value chart so you can show your thinking, or standard algorithm, 3 different strategies to help you multiply. Let's take a look back at what we learned today. We learned to use new tools to multiply 3 and 4-digit numbers. Tape diagrams can help us show our work. Partial product, that's the short way, or standard algorithm where we stretch it out, kind of like expanding the number. Tools help us to have choices just like building a house. You would not build a house with just a hammer. It would take you forever. The trick is you have to choose what works best for you. I might really like the partial product, but you might like using a hundreds chart so you can model and show your thinking. You have homework. I know, homework. Your job is to solve 716 times 6. So grab your pencil, write it down. Make sure that you are using the strategy that works best for you. Before I go, I want to celebrate you one more time. Good job, buddies. Keep up the good work. Miss you all and hope to see you soon.
Hi, it's Mark Dayette, the kindergarten through 4th grade PE teacher at Osborne, in the Osborne district at Encanto Elementary School. We've got some fun activities to do at home, some brain breaks, exercise, put all these together, get your heart going. You can do these inside, outside. I've got a member of my PE crew helping me out today, so we're gonna have some fun with these. We're gonna do one set of these. You can do as many as you want. You can do 1, 2, 4, 5, come back to them. What you wanna make sure though, before you start, always have some water, get yourself hydrated. If any time during the workout you don't feel good, take a break, get some more water. Ready, PE crew? All right, our first one is a neck warm-up. We're gonna stand with our hands on our hips. Just gonna move our neck back and forth to count to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, next one is a hip warm-up. Hands on our hips. Keep our feet together on the floor. We're just gonna move our hips back and forth. Count to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, our next one is jog in place. We're just gonna get our blood flowing a little bit more. Again, jog in place, stay where you're at. Make sure you keep, especially now, 6 feet apart from someone that you're working with. Again, count to 10. You ready, PE crew? Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, now we're gonna do some squats. That means we're gonna bend with our knees and come back up. If you can hold for just a second on your knee and then come up. 10 again. Here we, legs fat a little bit, shoulder width apart, and down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, this one is jumping jacks. This one we use both our feet and our hands. Start again with with our hands shoulder, or feet shoulder width apart, hands out over our head. Ready, begin. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, P crew, do you like to play basketball? Yeah. All right, this one is going to be practicing like you don't have a basketball. We're going to practice. It's called the bend and shoot. So we're going to bend down, kind of like our squat, and this time we're going to come up and pretend like we're shooting a basketball. 10 of these again. Ready? Begin. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, our next one are some punches. We're just going to be punching the air. Again, feet are going to be shoulder width apart, bent a little bit, and we're just going to punch out. Again, make sure you have 6 feet of distance for anything so you don't knock over anything in the house. Ready? Begin. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, our last one are kicks. Same motion as the punches. This time we're going to raise our legs. Again, 6 feet apart for social distancing, and make sure nothing's in the house that's going to get broken or outside. We want to try to get our feet as high as our chest, our waist. Ready? Begin. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, hopefully you had some fun with those. Get some exercise, get your heart going like mine is, and have some fun. Thank you, PE crew. Nice job.
Hello, I'm Mr. Meza from Clarendon Elementary. I will be taking you through week 1 distance learning for math. We're going to be focusing on place value. But a little bit before we dig in, a little bit about myself. I've been teaching at Clarendon for 5.5 years. I love playing volleyball, and I love traveling the world. I want to welcome all Osborne School students. We're doing this for all of 5th grade, so welcome our Longview Lancers, our Solano Tigers, and my Clarendon Cougars. So just a brief little agenda about what we're going to be going through today. Our weekly objective this week is that students will be able to identify, that's the key word, the value of a digit by looking at its place. So regarding the place value, where does that number lie in? Which one of those lanes that tells you what its place value is? A couple things to remember, the background knowledge. We have not done this for a long time. So schema, what do we already know about place value? A place value chart, I'm going to give you an example of, and then place values into the thousands. So 3 place values after the decimal point. So I know we haven't touched this since last August, probably. I think we did the first month of it across the district level. So here's a place value chart. And here you could see the ones is the 1, so it has it in word form and the number, and then tens, hundreds, and so forth. And then behind the decimal, we know that the first place value to the right of the decimal is the 10th place, emphasis on that THS, the tenths, hundredths, and thousands. So for this lesson, we're going to start off with 2 examples with just whole numbers, and then moving into 2 more examples that you're going to be seeing in your independent practice through Khan Academy. Here's my first example. What digit is in the tens? Notice that it says TENS, not tenths. That really is something that people tend to oversee, but this says what digit is in the tens place in the number 7,836. So the first thing that I do when I think of this number, I always go back to my schema and I think, where does this number lie? 7,836. So that in my mind, I kind of map out 7,000, give me 1 second so I can. Not that. Well, here you could see I would put the 7 here, 8 next to it, and then 3, and then 6. So what number, what digit is in the tens place? So I have the ones, tens, hundreds, thousands. So in this case, that would be the 3. For my second example, I'm going to do the same thing. What digit is in the hundreds place in the number 1,846? I'm going to call off my place values. So the 6 I know is in the ones, the 4 is in the tens, the 8 is in the hundreds, and the 1 is in the thousands. So what digit is in the hundreds place? That would be the 8. Starts easier with the whole numbers. Here's where we move into the second example that you'll see on Khan Academy. What is the place value of the 5 in the number 35 and 154 thousandths? We're going to get further into the word form and reading it correctly as we progress, but for now we're focusing directly where the arrow is pointing at that number. What is the place value of the 5 in this number? Well, I know that this, again, I call off the place values from largest to smallest. So 3 tens, 5 ones, 1 tenth, 500th, and 4 thousandths. So what is the place value of the 5 in this number? It would be 500. I always had my students put it in caps so that they would really remember and it really focused on that it was behind the decimal to the right. So 500, so that's its place value. All right, for my last example, what is the place value of the 9 and the number 1 and 369 thousandths? Again, I'm going to call off each place value. 1, 3 tenths, 6 hundredths, and 9 thousandths. So the answer to that would be 9 thousandths. And again, I always emphasize that by putting it in bold. The THS is a really key component to be able to do this successfully. All right, those are the 2 main skills that you're going to be using during your weekly work on your Google site. Just a reminder, you will have opportunities to solve similar problems, just like the 4 that I just went over, as well as on other problems that give you choice on your choice board that will be posted today. And last but not least, please don't forget to do the reflection form. That's really important for us teachers. Your own teacher will get back to you with individual feedback. If you need any, or if you tell us about your successes in the reflection form, lets us know that we're modeling these problems correctly. Hope everyone has a great Monday, and we're all excited to learn together with you during this distance learning. Have a great day. Bye.
Hi, I'm Mr. Stacy, and I teach 7th and 8th grade math at Osborne Middle School. I'm here today because there are way too many people that hear the word equation and cringe. They think that that's something that's unsolvable, or maybe you've had some difficulty solving them in the past. That's okay. What I want to do is I want to make sure that you are able to solve these even if you don't have paper involved. One of the biggest problems I've found with solving equations is that a lot of people don't understand what an equation is. What you're doing is you're subtracting things and adding things on both sides. What does that actually look like in real life? So what we're going to do today is we're going to take a look at how could you solve an equation even if you don't have paper. How can you move some Hershey's Kisses and Skittles around on a table and solve an equation? Now, if you were with us last week, you would know that we solved these with all positives, and every Hershey's Kiss in this case is going to be a positive variable, meaning we don't know how many Skittles each Hershey's Kiss is worth, but these silver ones, these are positives, and then every single Skittle is worth positive 1. Now in this case we've got green and yellow Skittles. Green and yellow Skittles represent positives. We'll get to red and orange Skittles later. Those are going to be negatives. But we worked with positive Hershey's Kisses, meaning this would be like positive 1x, and this would just be positive 1. All right? And so we solved an equation just like this. 5x plus 9 equals 3x plus 21. And I have this equation modeled right here on these plates. 5x, these are all positives, plus 9 Skittles, those are positive 9, so 5x plus 9 equals 3x plus, you're just going to have to trust me on this one, 21 positives. All right? And what we decided was we said, okay, our goal is to get just Hershey's Kisses on one side and just Skittles on the other side. And so in order to do that, I'm going to need to get rid of Hershey's Kisses on one of these sides. It's going to be easier to get rid of these. Okay, so I'm going to get rid of 3 Hershey's Kisses on the right, but in order to keep this equation, well, equal, I need to also take away 3 Hershey's Kisses on the left. Okay, so now I only have Hershey's Kisses on one side, but I have a bunch of Skittles here. I'm going to have to get rid of some of those. So I don't want any Skittles here with the Hershey's Kisses. X's, constants, don't want them. So I'm going to go ahead and I'm going to take away these 9 positives. But if I take away 9 positives on the left, I also need to take away 9 positives on the right, leaving me with only Hershey's Kisses on this side, only positive Skittles on that side. Awesome. Now what we can do is we can just take those off and we're going to match each Hershey's Kiss up with an equal number of Skittles. Let's see, maybe 6. Yeah, that works out. I divide them into 2 equal groups on each side, and I see that each Hershey's Kiss is equal to 6 positive Skittles. All right, so let's go back for a minute and let's check to see if that's actually true. If each Hershey's Kiss is worth 6 Skittles, let's count that out. So I'm going to reset my equation, and I have 5x plus 9 equals 3x plus 21 again. Again, we said that each Hershey's Kiss is worth 6 Skittles. So I have 21 Skittles here. So this is 6 Skittles, 12 Skittles, 18 Skittles plus 21 is going to give me 39. Over on this side, I've got 6, 12, 18, 24, 30 plus 9 equals 39. What that means is, if each Hershey's Kiss is worth 6, then both sides of this equation equal 39. So that's how we solve those equations. Now, this week, our objective is not just to be able to add when there's positives, but when there's also negatives. Before we can do that, we need to talk a bit about zero pairs. You might have heard of zero pairs. Hopefully you've heard of zero pairs. But let's start by looking at what happens when we add Skittles together. So I have 5 Skittles plus 3 Skittles, and that's going to equal, well, 5 positives plus 3 positives is going to give me 8 positives. So I just take them, I count them 1, 2, 3, 4, 5, 6, 7, 8 positives. That's equal to 8 positives. Okay, but what happens if instead I make these 3 negatives? Like I said, orange and red Skittles are negatives. Well, in this case, what's going to happen is every positive is going to cancel out with 1 negative. This positive and this negative, that equals 0. That's called a zero pair. Okay, this positive and this negative, they cancel each other out. Those are 0. This positive and this negative, they cancel each other out. Those are 0. What's left over? Well, that would be 2 positives. So I know that 5 positives plus 3 negatives make 2 positives. Okay, so now what would I have to do in order to make this equal 0? I don't want anything on this side. Well, I have 5 positives, 3 negatives. I could go, okay, well, if I add in 1 negative, that's going to be positive 4. 2 negatives is positive 3. 3 negatives is positive 2. Now I'm going to add in 4 negatives, that's positive 1. And my 5th negative, that gets me to 0. Positive 5 and negative 5 are additive inverses. When you add those together, they make 0. Positive 5 and negative 5 are a 0 pair. Okay? That's the important piece for what we're going to be doing today with our equations. All right? So let's make an equation that is going to use these negatives. All right? Let's look at 3x minus 6 equals negative 9. 3x minus 6 equals negative 9. Okay, I need to model this equation. All right, so I've got my 3x and I have my, wait a minute, negative 6. Okay, well, 3x minus 6, I'm going to need some negative Skittles this time. Okay, I have 3x minus 6, or plus negative 6, those are the same thing. And then, oh, on the other side, I'm going to need negative 9. Okay, so now I have 3x minus 6 equals negative 9. 3x minus 6 equals negative 9. All right, in this case, well, I don't have any positives to get rid of, but I guess I could subtract these negatives. If I take away 6 negatives on this side, oh, I have negatives that I can take away on this side as well. If I take away 6 negatives on this side as well, I've taken away the same thing on both sides. Took away 6 negatives, took away 6 negatives. And now I have each Hershey's Kiss. Hershey's Kisses on this side, Skittles on this side. If I divide those up into 3 equal groups, I see that each Hershey's Kiss equals negative 1. Perfect. So I could do it that way, but let's talk about what that might look like with additive inverses or 0 pairs. Okay, so I'm back to my original equation. I see 3x minus 6 equals negative 9. All right, previously, I took away these 6 negatives just by subtracting them, like taking them away. But if my goal is just to get rid of those negatives, how else could I do that? Well, I remember negative 6 and positive 6 together equals 0. So if I add 6 positives on this side, I've created a 0 pair. Those are going to go right away. Positive, negative 6, 0. They're gone. But since I did that, I also have to add 6 positives on the other side of the equation. Now, they're not all going to cancel each other out. 6 on this side canceled out all the negatives. 6 on this side is only going to take away 6 of the negatives, which is going to leave me with 3. Look at that. It's exactly the same as when I did it before. I've got my 3 Hershey's Kisses, my 3 variables, and each one of them is equal to 1 negative. I solved that equation without ever touching paper. So let's see what that looks like if I'm solving this on paper. All right, so remember in the equation, I had 3x, 3 Hershey's Kisses, and 6 negatives equals 9 negatives. What I decided to do the first time around was I took away negative 6 from both sides. I took away the 6 negatives, which meant that I had 0 there. It left me with 3 Hershey's Kisses was equal to, and if I had 9 negatives, took away 6 of them, I was left with 3 negatives. Remember, we had 3 Hershey's Kisses was equal to 3 negatives. Divided them into 3 equal groups on both sides, and I saw that each Hershey's Kiss was equal to negative 1, which means we did this correctly. we solved the whole thing correctly. So let's take a look at an equation that is just a little bit more complicated. All right, this time, I'm not going to tell you what the equation is. I'm going to model it. I'm going to put it out on these plates, and I want you to try to figure out what the equation is. All right? So as I'm setting this up, go ahead and take a look. What do you think this is going to be? Okay. All right, take a look here. I have my Hershey's Kisses, my negatives, my Hershey's Kisses, and in this case, I have positives on the other side. All right, if you said the equation was 6x minus 5 equals 2x plus 11, you were correct. All right, so that's the equation we're going to solve right now. Okay, here we go. I see positive variables on both sides of this equation. And so I really want to get variables or Hershey's Kisses only on one side of this equation. So what I'm going to do is I'm going to start by, I have two positives here. I could take two positives from this side. Okay, I took two positives off of both sides. Now I'm left with Hershey's Kisses only on one side of the equation. My problem is I want to get these Hershey's Kisses by themselves. I need to get rid of these 5. The problem now is that I can take away 5 negatives here, but I don't have any negatives to take away on the other side of the equation. So in order for me to take the same from both sides, I can't just take stuff away. How do I get rid of those negatives? Well, I'm thinking back to when we talked about those 0 pairs again, and I remember, well, wait a minute, 5 negatives and 5 positives equals 0. So if I had 5 positives to this side, and 5 positives to the other side, I've kept my equation balanced by adding the same amount on both sides, and these 5 negatives, 5 positives equal 0. They made a 0 pair. All right, and now I'm back to that same position I was before, where I can split up all of my Hershey's Kisses into 4 equal groups. Let's see, and I'm going to estimate. This is probably 4. There we go, 4 equal groups. Each Hershey's Kiss is worth 4 positive Skittles. I solved the equation without ever touching the paper. All right, let's check to make sure that that was actually correct, though. I'm going to go ahead and I'm going to put my equation back here. I've got 6x minus 5 is equal to 2x plus 11. So let's go ahead and check that. If every Hershey's Kiss is worth 4 positives, that means we've got 4, 8, plus 11 is 19. So 19 on this side. Let's see if it balances out. Each Hershey's Kiss is 4. 4, 8, 12, 16, 20, 24. Negatives are going to make me count backwards. 23, 22, 21, 20, 19. 19 equals 19. If each Hershey's Kiss is worth 4 positives, both plates equal 19, and this equation is true. We did it correctly. All right, let's take a look at what that looks like on paper. Okay? Same equation. I have 6x minus 5 equals 2x plus 11. Remember, my first move was get rid of all of the Hershey's Kisses I can on one side. So I took away those 2 Hershey's Kisses, leaving me none on the right, and 4 of them on the left. All right? I still had those 5 negatives and those 11 positives. Then I said I can't take away negatives on both sides because I don't have negatives on both sides. Instead, I could make this equal 0 by adding 5 positives. Negative 5, positive 5 is 0. Leaving me 4 Hershey's Kisses equals 16 positive Skittles. I divide both sides into 4 equal groups, and I found that each Hershey's Kiss, or 1 Hershey's Kiss, is equal to 4 Skittles, just like we saw a moment ago. So we did that one correctly as well. Last one. This one is going to bring in some strange pieces for sure. I'm going to set it up again, and I want you to guess what this equation would be. In this case, I'm going to bring in some red Hershey's Kisses. And I'm going to add in 7 of these positive Skittles. On the right-hand side, I'm going to add just 1 Hershey's Kiss, it's a positive, and just 1 negative Skittle. All right, if you're looking at this and you're saying, I think this is probably 1 to negative 3x plus 7 equals x minus 1, you are absolutely correct. There it is. Negative 3x plus 7 equals x minus 1. In this case, I'm going to have to be kind of clever with how I solve this because I want to get only Hershey's Kisses on one side and only Skittles on the other. But I really want to be working with positive x, so I don't want to be left with these negative Hershey's Kisses. So what am I going to do? I can't just take away 3 Hershey's Kisses because negative Hershey's Kisses. I don't have any negative Hershey's Kisses on this side to take away. So how do I get rid of these negative Hershey's Kisses? Wait a minute. I wonder if the same thing would apply with the Hershey's Kisses as with the Skittles. If I take 3 positive Hershey's Kisses and add those on both sides, well, I have a negative Hershey's Kiss and a positive Hershey's Kiss. Cancel each other out. That's a 0 pair, 0 pair, 0 pair. By adding positive 3 Hershey's Kisses on each side, I got rid of all of those negative Hershey's Kisses. Perfect. Now, I want the Hershey's Kisses on their own. I've got to deal with this negative Skittle. Okay, it's got to be the same thing. I can't take this just one away because this is a negative. These are all positives. If I'm going to take away a negative, I need to have a negative over here to get rid of. I don't have that. But again, thinking back to 0 pairs, if I add 1 positive to both sides of the equation, I've kept the equation balanced. These 2 are now gone because a negative and a positive make a 0 pair. They are now gone. I added 1 on this side as well just to make sure it was balanced, and I'm down to just positive Hershey's Kisses, just positive Skittles. And let's see. If I now take these, divide them up into 4 equal groups. All right, let's see. Can I make those into equal groups? You can always make them into equal groups, even if you have to cut the Skittles up a bit. There we go. Each Hershey's Kiss is worth 2 positive Skittles. All right, so we just solved that equation, again, without ever touching the paper. But we need to check because we never want to go forward and just assume that we got it right because we're good at math. All right, so let's go ahead. We're going to take 7 positive Skittles, 3 negative Hershey's Kisses, and remember we said each positive Hershey's Kiss was worth positive 2 Skittles. If a Hershey's Kiss is worth positive 2, a negative Hershey's Kiss has got to be worth negative 2. So I've got positive 2 minus 1 is 1. So our weight, if you will, is 1. On this side, I've got negative 2, negative 4, negative 6. Then I'm going to use these to go in the other direction. Adding 1, so negative 5, negative 4, negative 3, negative 2, negative 1, 0, positive 1. If each Hershey's Kiss is worth 2, that means that every negative Hershey's Kiss is worth negative 2, and both of these plates equal positive 1. So let's solve it on paper. Remember what I did before was I said I couldn't just get rid of the negative Hershey's Kisses, so I added 3 Hershey's Kisses to both sides. Those negatives and positives canceled each other out. I was left with 7 Skittles was equal to 4 Hershey's Kisses with that negative 1. Again, since I wanted to get rid of this negative Skittle, I added a positive Skittle on both sides. That made a 0 pair, leaving me with 8 Skittles was equal to 4 positive Hershey's Kisses. I divided those into 4 equal groups, and that left me with each Hershey's Kiss equaling 2. So what I just did, and what I know you could do, is solve that equation with positives and negatives on both sides of the equation without ever touching the paper. If you can do that, you've met our objective for today. So I challenge you to find some equations, have someone create some for you or find some somewhere else in a book or on the internet and set them up and try to solve them without touching paper. I can't wait to be back again next week where we can try to do this with some inequalities even. Until then, have a great week. Stay safe.
You've been watching Phoenix TV's Study Hall, brought to you by District 8 and our partners at Osborne and Roosevelt School Districts. Tune in Monday through Friday from 9 a.m. to 11 a.m. for more study hall. I hope you learned something today and keep up the great work.